Good morning to all. I am Pungurali from IT Department, Sri Shanmuga College of Engineering Technology. I am going to present a topic is searching and sorting techniques in DSC. First we start with searching techniques. Searching techniques basically two cadre. One is linear search and another one is binary search. It is in the next page. So first we start with searching techniques. Searching is the process of determining whether an element present in a given list of elements or not. So if the element is found, then the search is successful. If the element is found, then the search is successful. Otherwise, it is considered as an unsuccessful search. This is the searching process. It's nothing but we want to search one element. If we found that is called as successful. If not able to found, that means that is unsuccessful. So first we followed linear search. The linear search is the simplest searching technique. The search begins at one end of the list and searches for the required element one by one until the element is found or till the end of the list is reached. So if we want to, we have one set of numbers. Here the example number is present. Okay. So this is we are having the numbers are 3, 2, 18, 33, 21, 5, 99 and 42. These numbers are present here. This is the set of numbers. The key is we need a number is 33. That means we want to search number 33. So that's why we specify key. We have to search with this set of numbers. So if the 33 is present or not. So by using linear search means first we check the box. First box is present 3. 33 is present or not. And then it's going to the next box. Here itself 33 is present or. And the next that is move with another element 33 is present or. So that is this kind of process is known as called as that is the linear search. One by one linearly search one element and finally found the particular element that is called as the linear search operation. And this is routine integer linear, that is integer a and integer a and integer key. So first integer a and number and key. So integer I is equal to 0 and I less than a and I plus plus. If a is I, that means the key is, that is we have to match with key. So written a of a, finally we have to finish. We have to find the number. So this method only we are using to find the linear search technique. Next analysis. The best case 1 means, so that is 1 plus 2 plus up to n divided by 2. So n of n plus 1 divided by 2n and O of n. This is the analysis of linear search. And this is the advantages, that means it's simple. And also it does not require the list to be sorted in a particular, we don't want to sorted a list in a particular order. This is the advantages. And that means what is the disadvantages means inefficient for large sized list. So if it is we have to set up simple number, that means we use this. If it is that we have large sized list, that means that is inefficient. This is not efficient. This is the disadvantage. And let's move on the next type of searching, that is binary search. So the binary search requires the list to be sorted in ascending order. The binary search algorithm begins by comparing the element that is present at the middle of the list. That means if there is a match, then search ends and the location of the middle element is returned. If there is a mismatch with the middle element and the search element is less than middle element, then first part of the list is searched, otherwise second part of the list is searched. The process continues until the search element is equal to the middle element or the list contains only one element that is not equal to the search element. So here it's also we are having set of numbers, that is 1, 3, 4, 6, 8, 9, 11. This is the set of numbers we are having. So we want to search a number is 4. That means key. We represent as a key. So key is 4. So here one set of number is here. We want to search a number is 4 by using this binary search method. So first in the binary search method, we have to separate the two set of elements. Totally 1, 2, 3, 4, 5, 6, 7. 7 elements. We segregate the 7 elements by 2. That means first set of this element 3 and second set is another 3. The middle element is also 1. Okay. So compare with key with middle element 6. 6 is right or wrong. The 6 is not equal to 4. Okay. This is case whether it is match or not match. So 4 is less than or 6. So search first list. Okay. So first we are searching 3 is not equal to 4 and 4 is greater than 3. So search second list where 4 is equal to 4. So search is successful. The first one is we search and second one is also we search. And finally, third one is we search, that is 4 is equal to 4, that is so search is successful. Then that's all. This is sorting techniques. So basically sorting process is rearranging the given elements into either ascending or descending order. There are two types of sorting techniques. One is internal sorting and another one is external sorting. The internal sorting means if sorting operation is done in main memory of computer, then it is called as internal sorting. Example, bubble sort, insertion, selection sort, quick sort, radic sort and heap sort. These are all the comes under internal sorting and external sorting. So if sorting operation is done in secondary memory of computer, then it is called as external sorting. So the example multi-way merge, polyphase merge, these are all the example of external sorting. And this is, let's begin bubble sort. So the bubble sort is the oldest sorting method. It is also referred as sinking sort. That means, so sorting means like it is repeatedly move the smallest element to the lowest index position in the list. And it repeatedly compares two consecutive elements and moves smallest among them to the left. This process is repeated until all the elements are in the same correct order. So this is we are having one set of numbers, that is 56, 91, 35, 72 and 48, 68. This is we are having a set of number. Okay, so that means we have to arrange the number. Sorting it's nothing but this is arrange the order. So that is, so here 50 is the minimum smallest number, there is no. We want to arrange the order is first 35, second 48 and third 56 and fourth 68, fifth 91. We need this orderly, we need to sort this. So what are the techniques we are in the first phase? We 0, 1, 2, 3, 4, 5 we are considered here. Okay, so that means 72 is the fifth number and 91 is the sixth number. Okay, so first number, second number and third number, fourth number, fifth number, sixth number. Okay, this is the order. Okay, so 35, actually that means we are searching here first 56, 91, 35, 72, 48, 68. We use the order first primarily here. Okay, so first we want to 35 is the first number. So first the 56 is compared with first number. First 56 and 91. Which one is simple? So this is simple. So we move the next line. So which one is smallest? 56 or 35? So 35 is smallest. Simply just it's move here. And again, so 35 is compared with 72. And 35 is compared with 48. 35 is the compared with 68. So the entire schema, 35 only is the smallest number. So in the first phase 2, we have to put 35 here. Okay, so next and we have to move on the second stage. Second 91 is compared with second stage. So it is smallest with the first number and smallest with this and compare with this, which one is smallest, and compare this state, which one is smallest, and which one is the second smallest? 56, 48 is the second smallest. So 91 is replaced with here and 48 is replaced here, and this is the first smallest and this is the second smallest, and 35 and 48 is replaced here, and third one is 91. Again it is compared with whether it is this one which one is smallest. So we have to split compare. So by using this method, simply we arrange 0, 1, 2, 3, 4, 5 in this order. Finally, we get the sorting techniques. This is the bubble sort method techniques. And next, selection sort. The selection sort, smallest element in the list. When this element is found, it is swapped with the first element in the list. This is called a selection list. Then second smallest element in the list in the searched, when this element is found, it is swapped with the second element in the list. This process of selection and exchange continues until all the elements in the list have been sorted in ascending order. And this is the sorting, selection sort procedure. Similarly, 56, 91, 35, 72. The same set of numbers we are having. But if it is how it is short, that means this is we are using the first set 56, 91, 35, 72, 48 and 68. So first it's compared with this number. So which one is the smallest? And the second, which one is compare the second number, and third. So like a third is present. So by you, this is the technique, is the selection sort method. Okay, simply. And this is cell sort. So the cell sort is invented by Donald Shell, and it works by comparing elements that are distant. The distance between the comparison decreases as algorithm runs until lost phases. In lost phase, phase adjacent elements are compared. So shell sort is also called as diminishing increment sort. The shell sort uses a sequence H1, H2, Ht called increment sequence. After a phase, some increment Hk for every a of I less than or equal to a of I plus Hk, that is all the elements spaced Hk are a part of sorted. So the file is said to be Hk sorted. The increment sequence suggested by shell is Hk NB2. So next, this is first pass, how it passed. So we have one set of numbers 81, 94, 11, 93, 12, 35 and 95, 58. So okay, so this is first passed. So 81 and first is simple, and 94 and the second number, and 11 and so which one is number 95. Okay, so third one is 93 with the cell sorting with 28, and finally 12 with sorting with. After the first pass, the number should be rearranging in this method. And second pass, we have one set of number. In third pass also one set of numbers. So this is sorted array contains this method. Finally, we have sorting here. And next one is merge sort. This is the final. The merge sort uses divide and conquer method. The problem is divided into smaller problem and solved recursively. So finally, it merges two sorted lists. So on a divide and then give array of element into two half, and recursively sort the first half, second half of array elements, and take two input arrays A and B, output array C. The first element of array A array, B array are compared, then smaller element is stored in the output array C. Corresponding pointer is incremented. This step is repeated until the elements compare. So this is the basic algorithm for merge sort. So that's all. Finally, these are all the sorting techniques. And again, the merge sort uses divide and conquer method. So that's all. Over. Thank you. Thank you.